So we're going to build on the idea of combinations and permutations and be using a little bit of both of those lessons in this topic that we call combinatorics, okay? So we're going to have some scenarios where we want to do some different things with these groups, and we need to have a pretty firm grasp of both combinations and permutations in order to do that. So to start, I want you to think about how many different groups of two boys could be made from this group. And I'd encourage you to pause the video throughout this lesson and try to do the different tasks that we're doing together. So in this group, we have three boys, Ben, Carl, and Ed, denoted by the red hat. Okay, so when I'm asking how many groups of two boys can be made from this group, that's essentially the same thing as saying, what is 3 choose 2? How many different ways can I pick two things out of a group of 3? And we know that the formula for calculating this is 3 factorial times 2 factorial times 1 factorial, and that 1 factorial is pretty insignificant. So in other words, it's 3 times 2 times 1 over 2. So 3 different ways that this can be done. It's a pretty simple idea, right? And I could even write them all down because it's such a small number. I could do Ben and Carl, or I could do Carl and Ed, or I could do Ben and Ed. Those are the only 3 ways to do this. And the reason that we divided by this 2 factorial was because if I don't, then I'm also counting Carl Ben, Ed Carl, and Ed Ben as different groups. We're not doing that here. We just want to know how many different groups we can get. So I'm going to write a follow-up question down here then. If we were to select 2 people at random from this group, what is the probability that the 2 people selected would be boys? And so for this, we want to go back to our basic idea of probability, which is the probability of any event occurring is equal to the number of desired outcomes over the number of possible outcomes. So we're thinking of that as the overarching idea behind what we're calculating here. So the question is, what is the number of desired outcomes? Well, that's the outcome where you choose 2 boys. So we're thinking of it that way as our number of desired outcomes, that numerator, is the number of ways to choose 2 boys out of these 3 boys that we have. So 3 choose 2 is that number of desired outcomes, right? We're talking about 2 people being picked that are boys. There are 3 boys here, so how many different ways can I pick 2 of those 3 boys? Now, it's not as simple as just saying that the answer is that, because we're asking for a probability here. So what is the number of possible things that can happen when you pick 2 people from this group? Well, when I pick the first person, there are 5 people I could choose. And when I pick the second person, there are 4 people I could choose. So this is a situation where I am choosing 2 people from a group of 5. And that's going to give me the number of possible ways to do this. So this is saying, how many ways can I pick 2 people out of a group of 5? And this is saying, how many ways can I rearrange 2 of the 3 boys that are here? Okay, or pick 2 of the 3 boys that are here. So let's calculate this then. We already determined that the number of ways to choose 2 people out of a group of 3, with order not mattering, is equal to 3. And so let's calculate our denominator here. We'll use what we know about calculating these combinations. And this is going to be equal to 2 factorial times 3 factorial. All right, so if we want to work this out by hand, it's 5 times 4 times 3 times 2 over 2 times 3 times 2. And so we've got a lot of cancellation that can happen here. And that becomes a 2. So 3 out of 10. So the probability of 2 people being picked from this group at random and having those 2 people be boys is 30%, or 3 out of 10. Let's come up with a different scenario here and say that we're flipping a fair coin and we do it 4 times. What's the probability that you will get exactly 2 tails out of this? So again, we want to think about our basic probability formula. The probability of any event happening is the number of desired outcomes divided by the number of possible outcomes. So how do we calculate the number of desired outcomes here? Well, what we want is 2 of the same exact event to come out of this. So of 4 flips, we want to choose 2 of them to be tails. And so How many ways can we do that? Well, that's 4, choose 2. Now that's out of the number of possible things that can happen when you flip a coin 4 times. Every time you flip a fair coin, there are 2 things that can happen. So the number of possibilities is 2 times the number of possibilities on the second flip times the number of possibilities on the third and the fourth flip. So you end up just multiplying 2 by itself 4 times. So when we calculate this, it's going to be 4 factorial divided by 2 factorial divided by 2 factorial over 16, because 2 to the 4th is 16. And what ends up happening here is 4 times 3 times 2 over 2 times 2. We've got cancellation that goes on. And so that gives us a 6 in the numerator divided by 16, which is 3/8 if we reduce. Now you could check something like this by just making a tree diagram, right? Let's say this is the first flip. You could have gotten heads, you could have gotten tails. And then you flip again. Whichever path you took last time, you could now get heads or tails either time. And you can continue this, making a little tree diagram. This is our third flip. And then finally, we're going to have our fourth flip. So there are 16 branches in the end here. And if you write down what the results of each of these are, so this would be heads, 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 heads. Right? This is the result of flipping heads 4 times. That's obviously not one of the outcomes we're looking for here. We could do heads, 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 tails. That's not one either. We want 2 tails exactly. So where would we find exactly 2 tails? Well, this would be one of them. Heads, heads, tails, tails. That would be 1. So that's one of the 6. I could also have done heads, tails, tails. That's one of them. I could have done heads, tails, tails, heads. And a number of other ways to do this too, right? But if you go through and you check, and I'm just looking to find each of the combinations here, tails, heads, heads, tails, it's another, and then our final one would have been tails, heads, tails, heads. So if you actually listed out all of these, you would find that there are 6 of the 16 possibilities. So you can see, if you do it the long way, that this does work out. However, of course, this would be much more challenging if they said you flip a coin 18 times. Right now you got to draw 18 of these iterations of the branches. So you don't want to have to do that. So we want to be thinking of this in terms of using our probability formula in conjunction with what we know about combinations.